Hello, everyone. Welcome to Hacking Helm. I'm very happy to welcome Paul Czarkowski from Pivotal and Scott Rigby from Codeacademy to the stage. They will give you a presentation about Hacking Helm. So enjoy and thank you.
Thanks.
Hi, everyone. So we'll kick it right off. So we are indeed Paul and Scott. I work at Pivotal, where I'm a developer advocate, and Scott is a DevOps engineer.
Yep.
Cool.
That's me.
So we're going to talk about Helm, obviously, and really talking about the security of Helm. So kind of a rough idea of what we're going to go through up on the board there. So we're going to kind of start off, and Scott, why don't you start off by just giving us a brief intro to exactly what Helm is, really brief.
Sure, yeah. I mean, Helm is it's described as the package manager for Kubernetes. It is a package manager for Kubernetes. It is useful because it helps with bunching up your configurations, say a bunch of YAML configurations for your kube primitives. It's templated, so you don't have to repeat keys all over the place. There's Go templating, so there's logic in case you set this value, you can deploy these kinds of workloads, et cetera. And there are a lot of other benefits, including versioning, rollbacks. So it just really helps with deploying. The other really nice thing is Helm charts. I realize this is not all about Helm, but just a brief intro. They are meant to be reusable generally. So you really can write them any way you like if you want, but there are also a gazillion, or actually more like 600 something shareable, multi-purpose and reusable charts that are on the Chart Hub, which we'll link to later. So yeah, that's just a brief intro. Many of you probably know. In fact, just out of curiosity, how many people here use Helm now? Okay, so I really didn't need to say that. There might have been 2 people in the audience that don't. Yeah.
All right, cool. So there are, where's my clicker? There we go. So there are 4 main components of Helm, and we thought we'd quickly go through them, as that'll help set the stage for the security concerns about each one as we go through. So obviously we have the Helm client.
All right.
And it's basically just how you interact with Helm, right? So you have the Helm client installed on your laptop, and you're doing a Helm create to create a new chart, you're installing charts up into your Kubernetes cluster, you're interacting with a repository, etc., right? So that's pretty straightforward. And really there's not too many security concerns we have at kind of the Helm client side of things. So then we have Helm charts. So maybe, Scott, do you want to talk a little bit about
Sure, yeah. And so those configurations I was talking about are just, package it up in a tarball, and ultimately those, I think that's pretty, I kind of covered it earlier. It's really just, that package up there is the chart.
Yeah, so everyone here has used Helm, so you know what a Helm chart is.
Yeah.
A bunch of templates, a chart.yaml file, some metadata about the chart, and then a set of default values that will get rendered in if you don't override them.
Potentially your dependent charts, et cetera. That's kind of what we're covering here.
And then you have your Helm repository, which is like a server up on the internet somewhere that is hosting those Helm packages, so those tarballs. So they host those tarballs, plus some sort of index file to say what is available on that server. And you can host a Helm repo on anything, because it's just static files, so up on S3 or on GitHub pages. The Helm community actually has a tool called Chart Releaser, which is designed to host those chart repo on GitHub using GitHub releases and GitHub pages. So that's quite useful. And of course, if you're using that, you're sort of offsetting a lot of your security stuff to GitHub or to S3 or whatever.
Just out of curiosity, I am very curious now, because you're all here and most of you know about Helm. How many people are hosting their own Helm repos right now? Okay, awesome. Wow, that is surprisingly great.
Yeah.
And we'll link to the hub if you don't already have your repos linked to the Helm hub now. That'll be up here.
Cool. So we also have the tillerless server, right? And it runs inside your Kubernetes cluster, as you're all aware. And it's probably one of the most controversial parts of Helm. And usually when people are talking about Helm security, they're talking about Tiller. And so we'll talk about a few things around Tiller and securing it, and also how to do naughty things if it's not secure. But really, it's doing like the rendering the templates, deploying resources, etc. You install it by using the Helm client. You do Helm init. Hopefully, you're actually doing a little bit more than just Helm init, but that's kind of the basic, simple command to install it. And it creates a deployment in the kube system namespace, and it creates a service of type cluster IP, right? So that's just kind of a command line sort of description of what I just talked through. Scott, do you want to quickly go through the Helm chart workflow, what exactly happens as you're doing like a Helm install, and then we'll start to move on to the security bit.
Sure. Yeah. Okay. Right. Right. There we go. Yeah. So right now we're going to be covering the general use case. We realize there are a number of different workarounds and ways to handle this, and we'll cover some of those briefly here as we're covering some of the hacks. But really, we're just talking about a Helm install where you are installing your chart either from, in this case, from a repo, right? So the Helm client makes a call to your Helm repo. It goes ahead and then downloads that chart package, essentially like just grabs that tarball that it finds from the metadata. The package it's unpacked and its default values are going to be used. It goes ahead and renders out the templates, and it passes that information to the Kube API to install or upgrade the application, including wait, did we already cover? Yeah, including any values that you set, any custom value files, or any values you set from the command line. That information is all passed to the Tiller server. So all that so far has happened locally, right? All that information is all passed to the Tiller server, which goes ahead and renders those templates and works with the Kube API to deploy. Yeah. Right.
So that brings up a number of security concerns. So if we move on to the next, yeah, let me grab it. So is the Helm repo secure? Is it using SSL? Are your charts signed? Where are you storing that values file?
Sorry, and if your charts are signed, are you validating that signature? Yeah.
Where are we storing the values? Especially for the values that are your passwords and secrets and keys and stuff. And is that secure? Are they being stored in plain text in Git? And then of course, is Tiller secure? Who's able to access it? And are my workloads protected from somebody else's workloads? Is what I've installed through Tiller accessible by someone else who's also got Helm and that same cluster? So when we talk about securing Tiller and the other components, first I think we really need to talk about the tenancy model that you've chosen for your Kubernetes cluster before you decide how exactly you want to secure Helm, because your Helm tenancy is kind of roughly going to reflect your Kubernetes tenancy.
Or should at least.
Yeah. And so we came up with kind of these four models where either everyone is a sysadmin and everyone is the cluster admin, right? In which case, you effectively don't really have a tenancy model, everyone is God. And then you have every user has their own namespace, so you start using RBAC and you're locking people down to just a particular namespace. Or maybe it's each team or project has a namespace, right? Or then there's also that, if you're doing multi-cluster, you've got every team has their own cluster. And that often, a lot of folks go back to that, everyone that has access to that cluster is kind of the god of that cluster. And you just email around that X509 certificate and nobody cares, right? Well, hopefully you don't quite do that. Yeah, that's it. Everyone's cluster admin, you don't really care. In that case, you don't really need to worry too much about securing Helm from each other. If you're doing the namespace model, if you're using namespaces as a tenancy model, then you do need to start thinking about how am I going to protect each namespace from not just the users, but from Tiller and from how Helm works. And so that's when we're okay, do we need to install Helm, Tiller into its own namespace or something like that? And then obviously, again, if each team has their own cluster, and everyone's kind of a super user in that cluster, then you we can have one big Tiller. We're not really trying to protect things from each other because everyone has already got on Kubernetes, so it doesn't really matter if Helm also has some elevated permissions across the clusters. And then we have to think about are we doing RBAC? Are we doing ABAC? Like, what's going on? Well, first of all, you're not doing ABAC. That's kind of a relic from a long time ago. You shouldn't be doing it, which means you're not just doing that Helm init. You're actually doing creating a role and doing some other stuff. Right? So you're going to do RBAC. Scott.
Yeah. So. Which slide are we actually? Oh, okay. Yeah. So basically, yeah, what we're talking about now is just making sure that we have tiller set up for whatever model we've chosen, right? There are two real types of users we're talking about. One is, the normal service account user. The other is actual users, humans. First of all, we'll talk about, tiller is in this case pretty much a robot, right? For us, it's a service account. Generally, you're going. Actually, why don't you take
okay.
this
So,
time,
you want to lock down the resources to the bare minimum required for that robot user, right? Tiller itself gets a service account. And then you'll do role bindings and cluster role bindings to specify, is it accessing the whole cluster or is it accessing specific namespaces?
Exactly, to match the tenancy model that we mentioned earlier.
Yeah. And again, you're not using ABAC because it's not 3 years ago. User accounts, so this is your users, so the people that are going to be running Helm, so the Helm client, and it'll also be doing like kubectl get nodes and kubectl get pods and stuff like that. And so usually you think of kind of having your super user, which is kind of got cluster admin rights, and then a regular user that probably only has access to a set number of namespaces, and maybe also has a reduced amount of resources they have access to. And so when you're locking down tiller, you need to be thinking about that tenancy model and who currently has access to like cluster admin, who has access to specific namespaces.
Yeah, and I'm not sure if we really noted this yet, but the point is that if tiller is installed cluster-wide in the tenancy model where you actually do have user access to specific namespaces, there is really the big problem, right? Because tiller has cluster admin access now, and you can access tiller using ultimately kube proxy from your client. So now you are somehow granted that cluster admin access, and maybe the person that's setting up your cluster has no clue, or maybe that person is you, right? And are not thinking about the fact that this privilege is given to the users. So we're talking about privilege escalation.
Right. So let's have a look at what that looks like. So you can see, first of all, we're installing tiller in a somewhat better way now. We're creating a cluster role binding, we're giving it a service account, etc. But this is giving it a cluster admin rights, right? So a person who is not cluster admin but has access to Helm is effectively inheriting Helm's cluster admin rights. And so this up here is if everyone is cluster admin, it's kind of okay to install Helm this way, depending on how secure you are. But if you're actually restricting people to namespaces, you probably want to do something like this, where you're creating a service account in a specific namespace. You can see I'm doing the -n to denote a namespace. I'm creating a specific role in that namespace, and I'm assigning that role via role binding to tiller in that namespace. And then when I do the Helm init, I specify which namespace to use. And then when I run Helm install, I also specify that. And of course, you can do it via environment variables, so you don't actually have to type in the --tiller namespace every time. And so doing this, you would install a tiller for kind of every user or every namespace, depending on exactly how you're doing it. And then that Helm, that tiller user will be restricted in a similar way to what your Kubernetes users are restricted to. So you end up with a slightly more secure model, but you do end up with a bunch of tillers lying around. I do a workshop where I kind of do that model, and I think I install tiller 100 times in a cluster, right? Which isn't too bad because it doesn't take up a lot of resources, but it is something to think about. So once you've got it installed, there's some attack vectors of running things from actually inside the cluster and being able to access tiller from inside the cluster. So Scott, why don't you go through that?
Okay, yeah. Oops. I skip ahead accidentally. Yeah, right. So did we list out these attack vectors? Let's see. In any case, yeah. So basically, the three are some similar to what we had just mentioned a second ago, a lower privileged user trying to gain higher access. The second is some bad actor in a pod trying to access Tiller from inside your cluster. So like you've installed something and you're not really sure where it came from, right? Or it slipped through. Someone in that pod can go ahead and try to contact Tiller, and we'll talk about it in a second, and get that cluster admin access we just mentioned. And the other is to launch extra pods. And then the last is when you just have a really like creepy chart maintainer, right? A naughty chart author who's you do Helm install some chart and what's in it? What's it doing? If you didn't inspect it carefully, it could be doing some interesting things. So the first one we can talk about the service, right?
Yeah. So when you do a Tiller init, right, it installs a deployment for Tiller, but it also deploys a service for Tiller. And if you have, and it has a cluster IP and a cluster port, right? So if you have access to that service, which like pretty much anything on the cluster would by default, you can start doing things. So you can see from this example, I'm just running a random pod that has Helm in it, and I'm starting to run Helm commands. And you can see I can like do a Helm version and see what versions are running, etc. Right? So without really having without any privileges apart from exec into one pod somewhere, whether that's because I'm running kubectl exec or because I've like hacked your WordPress server or whatever, I now have access to Tiller on your cluster, and then I am inheriting whatever access Tiller has in your cluster. So suddenly, from being someone that should be unprivileged, I now have like full cluster admin rights in your cluster, so I can do bad things. So obviously, one of the first things you can do is just go ahead and delete that service, right? It is not really needed for humans to deal with Tiller, so you just do kubectl delete and get rid of it. But a patient user would still be able to access Tiller if they can figure out the IP address of that pod. And so that's kind of what I'm showing here, right? The first attempt is using what would have been the service, it's failing. The second attempt, I kind of figured out the IP address of the Tiller pod, and then I can still actually run commands and do stuff.
Right, so it's still good to do, it's just one extra layer of security.
So how do we solve that?
Well, generally you want to, and note that this still doesn't solve it all for you, but an additional layer is, you kill that service, then you make sure that Tiller is only listening on localhost. That's super important, and there's there are some links back here. There's a really great Bitnami article that goes through this little section of the talk and gives fantastic examples of how to do that. So you don't have to kind of like quickly sketch this out.
Yeah, but you can see here we're actually just patching the existing deployment and just changing the container command, right, to and args to just be listen to localhost. So now it's just listening to localhost, so anything outside of the pod can no longer access it, right? So it doesn't really matter where you are in the cluster. You can't get to localhost in that pod unless you're actually a member of that pod, which you're not.
Right, and by the way, the reason that you want to restrict to localhost, in case it's not clear, is that when Helm client, your binary from your workstation or whatever is talking to Tiller, it's using kube proxy, and that's essentially talking over localhost.
Yeah, so when you do kubectl proxy, which is what Helm client does, it basically proxies you through to localhost on that pod, which means running Helm install, etc., will still work from a human perspective. And Helm proxy, kubectl proxy is controlled by RBAC. So as long as you're got the right RBAC settings, users should only be able to access the tillers that they have access to via the Kubernetes RBAC. If you need to access Helm from inside of your cluster, which there are some legitimate reasons. If you're running CI inside of the cluster, you may need to access Helm to do Helm install or Helm upgrade or whatever. If you have the Helm installed and you have the right kubeconfig file, it should continue to work as you expect. But sometimes you want to actually talk to the Tiller API. And if you want to talk to the Tiller API, you actually need that service back. So you need to actually secure that Tiller service some other way. And you do that by using TLS verification. So effectively, you're creating a CA and a bunch of certs and keys, and you tell Tiller that it should trust anything that's been signed with that same CA. And then when you're running Helm client commands, you provide those certificates and etc. And as long as those certs match and are signed by the right CA, you can now run Helm commands effectively. Now, it is really painful to set up, so most people don't do it. So usually you just don't do, there's not a lot of reasons to access the Helm API from inside the cluster. So it's not something you would really need to do. I have seen folks actually force everyone to actually do this for users to access it. But I feel that is usually a little bit overkill. Like you've already got your your Kubernetes RBAC sort of giving you some protections anyway. So I feel like this is a little bit maybe over the top. But everyone has different ideas of what is acceptable risk when it comes to security.
Yeah, and it's a tool that's meant to be flexible. So if you want to run your CI in cluster, go for it. You just need to make sure, the goal of that is, if it's not clear, it probably is to most of you, but you just need to make sure that the actor calling those commands really is, Tiller needs to know they are who they say they are.
Yeah, and then I guess the other thing you could do is you can use network security policies. We were actually talking about that a little bit earlier, to restrict who can access the pod. And you could even maybe do something with sidecars, have like a proxy in a sidecar, and have that proxy have like different auth mechanisms to access it. So there's a few ways you can work around it. So why don't we move on and talk about naughty chart authors, our favorite, right? So maybe Scott, you want to talk a little bit about this?
Yeah, right. So I kind of indicated this earlier that if you, let's even say you're installing from the Helm community charts monorepo right now, and you do a Helm install stable whatever, right? Stable WordPress or something like this.
Stable WordPress, well, you're already hacked.
Sorry.
That is definitely a naughty chart author right there.
So apps can definitely limit you, but let's say someone, for some weird reason, snuck in a PR that no one noticed, and it's got some whether they're Bitcoin miners or something even more malicious that might not just sort of eat up your resources, but actually mess up your resources. That could be in there.
So how do we protect against that?
You really can't. You can't entirely. Of course, you can't entirely. You have to inspect what you're installing. But there are a couple of different tools to help limit that attack surface.
Right. So first of all, you have pod security policies, but they're really hard, and we're really lazy, so no one uses them. Sorry. You have admission controller webhooks.
Oh, wait a second. Just because I did this twice before. You don't have to be honest, of course, but who is running pod security policies on all of your workloads? That's pretty close to what I thought. Yeah,
5 people.
No, I'm with you. Yeah, I'm definitely with you.
Craig definitely is. He's a good boy. Good work, Craig. And in fact, I think Craig will tell you how to do that in his book, Managing Kubernetes Clusters, which he'll be signing at 3:30. There you go. There's a plug for you. So pod security policies, admission controller webhooks are great. You tie them into a tool like Open Policy Agent, and then you can use this. I think it's the DSL for that is Riga. And you can do very interesting policies around what is and isn't allowed to be done. So if it's a deployment, the image must come from my registry. Maybe a particular type of user can't create a service of type load balancer. Maybe you can't launch an image with the name Bitcoin in the name. A lot of stuff like that. So it's really useful.
It looked great, yeah.
Yeah, and then Gareth Rushgrove actually gave a talk yesterday on actually shifting the Open Policy Agent tests all the way left to doing it with unit tests. And so he has this tool called ConfTest that will actually just basically look through your kube manifests before they're actually deployed, and will run those open policy agent tests against it. And so you can put that in your CI system and get really fast feedback on whether or not you're doing something that is going to violate the rules that you're putting in place inside of your clusters. So if you're not doing admission control or webhooks, if you're not using OPA or a tool like OPA, I highly recommend it. And then you also have the mutating controller hooks, so you can actually like intercept and change things that the naughty chart authors are doing. Say you want them to always make sure they have certain annotations or stuff. You can actually modify their deployments to have the right annotations, which can be super useful as well. Yeah, so that's kind of all you can really do for naughty chart authors, is have policies in place and enforce those policies around really obvious things. And you can also enforce best practices as well. So really, really useful.
Yeah, right. So the other thing is, right, like you can't hack what isn't there. So you could just not use Tiller at all. You know, that is one way to. And again, we're talking about Helm, the current Helm version, Helm 2 here. That is one way to do it. You can, you know, you can use chart templates to go ahead and render. You can still use charts. You could, you know, render those templates. I think that's what this command is doing, right? Yeah. You can render those templates using that come out of that chart, and then just pass those directly to kube control. That is certainly one way. What you lose from that is, you know, you lose Helm's versioning and rollback capabilities. Basically, you're losing the deployment niceties that, and what some people consider, you know, like requirements for them that Tiller gives you.
Yeah, and this is a pretty common pattern that I see, and you even see other open source tools using it, like Istio does all of their manifests in Helm, but they run Helm template and share the actual rendered out results. They don't actually distribute it with Helm. So it's definitely, even if you're not distributing it with Helm, using Helm to do the templating is still super useful. And if you do this, you don't need Tiller. You'll also have the tillerless Helm plugin that instead of running Tiller up in your Kubernetes cluster, it actually runs it on your local system. Because really, Tiller is just working with the Kubernetes API, so there's no reason it has to run inside the cluster. And so when you use the Helm Tiller plugin, you tell it to start, you run your Helm commands, and then you tell it to stop, right? So Tiller is only running for the length of time that you are doing this. So it's called tillerless, but it's not really tillerless. It's like occasional Tiller.
It's like serverless. It's tillerless. Now, Remus, one of the original Helm authors and who works at JFrog, wrote the tillerless plugin. I have never used it myself, so I can't give my stamp of endorsement, but I looked it over and it looks like a really great pattern, and I know a lot of people use it. So definitely something to consider.
Right, so that's kind of Tiller. We've secured, Tiller is solved, everyone is unhackable now, right? So what other things can go wrong? Do you want to talk a little bit about this kind of, like the way that values can leak, secrets can leak, et cetera?
Yeah, absolutely. So are we on the value leak slide yet? Okay, yeah. So, the sad face, yes. Yeah, so this was actually a pretty interesting thing. It was an interesting thing for me to learn because I won't go into too many horror stories, but I did not know immediately when I first started using Helm that I wasn't quite aware of the tenancy, how Helm's tenancy model, or say Tiller's tenancy model, can match your Kubernetes tenancy model or be mismatched. So for instance, when we were talking before about, let's say you're using you're doing multi-tenancy with, you've got either each user or each project or each team having their own namespace, and you've got all of that locked down really well inside of a cluster, right? And then this situation we talked earlier where perhaps you've got Helm installed globally, or sorry, Tiller installed globally. When you install a chart and pass values to that chart that override the default values, all of those values are stored somewhere. You know, Tiller has to in order to be able to do rollbacks and have that functionality, they have to store it. So where are they stored? They're stored in config maps wherever you install tiller. So if you install it globally in kube system, those config maps for every single chart release, the values that you pass, your custom values, are stored in that config map. So if you see where I'm going here, if someone normally, say you're still limited to a namespace, you can't really just go inside of kube system and get that config map, right? So it's protected that way. But Helm has this awesome command called Helm get values, and you can still get the values from that otherwise protected config map for someone else, some other team's namespace. You can get all of the, clearly, again, if everyone has cluster admin access, this isn't really a problem for you. But if you do have that other tenancy model, this can be a really big problem for you.
Yeah, so you can see with this example, right? We're running Helm LS, and we're getting the release names of all of the charts that are installed. And then we're doing a Helm get values, and then we're grepping for the word pass, right? So we're literally going to get anything with like password written in it that's stored in a Helm value. So if you get access to Helm, you can run this, and it's not great. And you don't have a ton of protection against this, so hopefully Helm 3 without tiller will solve that. So that's why it's super important to lock down Helm and lock down tiller to be just the users who should be able to access it for the particular namespaces to be able to do it. Otherwise, you do have ways to leak values, leak secrets through Helm itself. And you can see on this previous slide, you can do a get config map, the release name and the version, and you can get all of the values. They are base 64 encoded, but like, so what? That's just an extra command to decode them, right? You should also be storing your Helm charts and values in version control. I assume everyone is storing them in Git, right? Because we're doing GitOps, we're doing CI/CD, etc. Infrastructure as code, so it's all up there. So now, like, how are you storing your secrets? Are you storing them in GitHub with the other values, or are you storing them somewhere else? And you shouldn't be storing them in GitHub, even if it's a private GitHub enterprise or whatever. Like, it's still secrets in plain text on something that, in theory, a bad actor could get access to. And I certainly don't control who has access to do weird things to my GitHub enterprise. That's some other team. So I shouldn't be trusting that. We should be thinking about that zero trust. So how do we want to, like, where do we store our values, Scott?
Yeah, I mean, right. So like some of this isn't really specific to Helm, but then it does really relate to what we were just talking about, right? Obviously, don't put passwords and API keys in your Git repos, right? Of course, but clearly, there are ways to get around it. There are ways to work around it. So. One way is to store encrypted secrets, right? Like, say, using Vault or using some other homemade or another project that does encryption, right? One way or another. But then, of course, you have to have some mechanism to decrypt that properly, and you need to make sure that that's running with how you set up your releases with Tiller. You could do, and to be quite honest, this is what I still do. This is what I do just because it's kind of the most foolproof, but it is also a little bit manual. But you could, do kube control create for every single secret that you need. Again, I'm not really advocating for that. From a security point of view, it's a good way to do it, but from a usability point of view and a workflow point of view, it might not be as nice as what you want. So there are some other options. There's that lovely project.
The Bitnami tools, sealed secrets.
Yeah.
And then, of course, you've probably got some form of like encryption storage available to you. So whatever you have, it's HashiCorp's Vault or something like that, you can probably use that. I've certainly used like a shared KeyPass file, and then when you want to actually create secrets, you're just creating secrets and putting that in there.
Yep.
Now, when you're actually writing Helm charts, a lot of chart authors will actually just put the like secret values as values in like the values file. I prefer to provide an option to also give a already created secret, and if that's set, then you don't actually render out those secrets. And then it's on you to then create those secrets before you run the Helm install, however you would do that. So like if it's like a key.json file, you can like do a, create secret from file or whatever. If it's up in Vault, HashiCorp Vault, there are ways to get values into secrets from HashiCorp Vault, etc.
Yeah, and a lot of the community charts do have that logic built into them. Not every single one. So if you see, one that doesn't, you could feel free to like add the 812 pull request that's open right now. Anyway. That's almost too sad to be funny, but I have seen people use what you were talking about, Paul, and tie a service in with, let's say, LastPass API and automatically creates. We have 1 minute. Oh, let's move on.
Yeah. So we just wanted to kind of finish with like Helm 3 is coming. So like, did everything we just talked about? Does it even matter? And well, kind of yes and no. Like Tiller is going away. But it's probably going to be a while before a lot of us adopt Helm 3 because we have so much invested into the current version of Helm. And so Helm 3 will move towards using CRDs and other more like Kubernetes native things, and we won't have Tiller. But really, we're just going to be shifting around the attack vector, and we're probably going to be opening up more security vulnerabilities than we're closing, right, when we get rid of Tiller. Because we're terrible. So like you still need to keep all of these concepts in mind and be thinking about the tenancy model of your cluster and that sort of stuff. So we're really looking forward to, with Helm 3, all the new and surprising ways that we're going to get hacked and people are going to get free bitcoins that they're going to mine off our clusters. So that is kind of it. So we have kind of, that's what we went through. Here's some references and further reading. A lot of the stuff we talked through, especially the blocks of text demos, like patching the deployment, are in that Bitnami blog, so that's really worth reading. And there's some other links there. And these will be shared somewhere at the end of the event if you want to get access to these. And so that is it, and we are right at time, so we probably don't have time for questions.
Is that with the Q&A?
No, you're out of time.
We did want Q&A. Yeah, yes. We'll be out there if you want to pull us aside. So thank you all very much.
Thank you.